Hello students, in yesterday's class we have derived the equation for magnitude and direction of the resultant of two vectors acting at a point. So the magnitude equation was r is equal to square root of p square plus q square plus 2pq cos theta. Yes, this was the equation as what we have derived in our previous classes. Okay, so we'll consider this equation and we'll discuss some of the cases. Right now we'll have cases if theta is equal to 0 degree. What happens if theta is equal to 0 degree? So cos theta, which is 0, which is equal to 1, right? Cos theta, which is equal to 0. Theta is 0. So which is 1. So we'll substitute this in equation. What happens? P square plus q square plus 2pq. Because cos theta is 1 as theta is 0 degree. Or we can write it as r is equal to square root of p plus q the whole square. Right? We can write this as maximum. R maximum is equal to p plus q. Why? Because the magnitude of the resultant is, see here, the magnitude of the resultant is equal to the sum that is p plus q, sum of the magnitude of the individual vector, right? Because p and q are the individual vectors as you have seen while deriving, and this r is the resultant. So we can write it as the magnitude of the resultant is equal to the sum of the magnitude of the individual vectors. This is the first case. So next case is if theta is equal to 180 degree. What happens? Cos 180 degree is minus 1. So we substitute this in equation, that is p square plus q square. So minus will be, we can write it as 2pq because cos 180 is minus 1. So we can write it this as a minus b whole square, that is p minus q whole square, right? P minus q whole square, or r minimum, the resultant is minimum, is p minus q. Or we can write it as similarly the magnitude of the resultant is equal to the difference. Here there is a difference between the magnitude of individual vectors. See here, the magnitude of the resultant is equal. This magnitude of the resultant is equal to the difference because p minus q as theta is equal to 180 degree. This is the second case. This is the first case. Next, we will have the third case, which is the last case. Theta is equal to 90 degree. Cos 90 is 0. What happens to the equation? R is equal to square root of this whole term will be 0 if theta is equal to 0. 9. Theta is equal to 0. So p square plus q square. So these are the three cases. When theta is 0 degree, what happens to this equation? When theta is 180 degree, what happens to this equation? And theta is 90 degree, what happens to this equation? These are the three cases we have to discuss after the derivation of this equation. Okay? Hope this is clear for you. Next, we will study the resolution of vector. Let us define it. The process of splitting a vector into two or more vectors is known as resolution of vector. Okay, is known as resolution of vector. So from the examination point of view, they will ask the question like, derive the two mutually perpendicular component of a vector. So this is important for 5 marks. Derive the two mutually perpendicular component of a vector. And also they tell what is resolution of vector, and then they'll ask derive the two mutually perpendicular component of a vector. So let's derive it. Derive. For this derivation, let us draw a vector r, okay, from the point O, and we will make an angle theta with this r to x-axis, that is A. These are the two mutually perpendicular components, okay, and this is as C and this is B, okay, and this is vector Q will mark and this vector P, okay. So we can write it as OA is equal to vector P and OC is equal to vector Q. Got cleared? These are the mutually perpendicular components, such that we know that by vector addition R is equal to vector P plus Q. You know this? Okay. So now from triangle OAB, we'll take sine theta. What is sine theta? Opposite by hypotenuse. That is AB by, here is the sine theta, AB by OB. Or we can write this as sine theta is equal to, what is AB? AB is, here is the AB, this is OB, this is, here is AB, this is Q, because these are equal. Q by OB is R, right? Or Q is equal to R sine theta, right? This is the equation for one component, that is this component. Next, we'll consider cos theta. This is equation 1. Next, we'll consider cos theta. Cos theta is equal to what? Adjacent by hypotenuse. That is OA by OB. What is OA? P by R, or P is equal to R cos theta. We'll consider this as equation 2. So therefore, the two mutually perpendicular of R are R cos theta and R sin theta. So this is the two mutually perpendicular. These are the two mutually perpendicular, as I said you. Mutually perpendicular. Right? The mutually perpendicular are, you can write it as, therefore, the two mutually perpendicular components of R. Derive the two mutual perpendicular component of a vector, that is, the vector is R. So what we have come to the conclusion that the two mutually perpendicular component of R, these are the two mutually perpendicular component R, that is P and Q, what they will be from equation 1 and 2, that is R cos theta and R sin theta. So this is the required equation. It's important. Derive it, and before going to derive any of the derivations, I'll tell you, if you draw a diagram, you have to write like a statement. Consider this R is a vector. You have to write. Don't go on writing like this. You have to write consider the vector R. That is the skill of making the perfect notes. Okay, you have to write consider R is a vector and OA is this x-axis which is perpendicular, this OC is perpendicular. You have to write the statements and then you have to start writing the steps. Okay, in that particular way, if you derive, they will give you out of out, that is 5 out of out. So hope this derivation is clear.